Hello everyone. Today let's solve the problem number 427. Construct quad tree. Right. So what the question states here, we are given n into n matrix grid of only zeros and ones. So we have been given n into n. So just give me a second here. 1 second. Yeah. N into n means here we have been given 2 into 2. Right. So 2 into 2 for this particular example. Right, so we have been given n into n matrix grid of only zeros and ones, only zeros and ones, right? Just keep this in mind. We are given n into n matrix grid of only zeros and ones. Build a quad tree such that each node represents a uniform grid region. We have to build a quad tree that in such a way that each node represents a uniform grid region. So uniform grid region means it should consist of zeros and ones as well. Only zeros and ones. Only zeros and ones. All zeros and all ones, right? If not uniform, then divide the grid into four equal subgrids and recursively build children. So this part is very important. Just listen to this part again. Here, if not uniform, right, we have to build the quad tree such that each node represents a uniform grid region that consists of all zeros and ones. If not uniform, if we cannot, or if not uniform, then we have to divide the grid into four equal sub grids. We have to divide the grid into four equal sub grids. We have to divide the grid into four equal subgrids, and we have to recursively build the children. We have to recursively build the children. So this is what they have asked for the output for this one. The quad is this thing, 1 0 1 1 1 1 1 0, and the root, we have to include the root as well. So 0 1 is included as well. So let's consider same thing for the approach. You'll get to know this thing better. So what I'll do, for discussing the approach, I'll be considering the first example. We'll be discussing what data structures we'll be making use of in this one, within the code that we'll be writing in the future, right? Those are all the things that we'll be discussing in the approach. So whatever we discuss in the approach, try to implement for the example 2. I'll be showing for the example 1. You can just go through the example 2, right? So here I hope the question part is completely clear, man. What we need to do, I have said this one in simple terms. We are given n into n matrix grid of only zeros and ones. We have to build a quad tree such that each node represents a uniform grid region. This is what the question states. You can just forget all these things. I just want to tell you, we are given n into n matrix grid of only zeros and ones, right? So we have to build a quad tree such that each node represents a uniform grid region. That's what we need to do. If it is not uniform, the one more condition or the criteria that they have given here is, if not uniform, then we have to divide the grid into four equal subgrids and recursively we have to build the children. So this is it for the question. So this is it for the question. Forget everything. So this is it for the question. So here they have given the definition for the quad tree node. They have given the definition for the quad tree node. So we don't have to include this one. We don't have to include within the solution. They have already done that part, and they have showed us the definition of a quad tree node as well. So I'll just clear this one. You can just go through this one. You can just go through this one if you want to. So I'll just clear this one so that this looks clean, right? So first let's discuss the approach followed by the complexities, and then let's write the code, right? So here I'll just consider first example. I'll just consider first example that they have given in the question. So this one here, see, we have considered the same first example that they have given in the question, 0 1 1 0. The output that we need to get here is, this one is root along with the quad node. So this one is the quad tree, right? So that we can say, this one is the node basically, right? Nothing but the quad tree basically is 1 0 1 1 1 1 1 0, and this is nothing but the root, right? So this is fine. So here the approach that we'll be going with, for this particular question will be to solve this particular problem would be divide and conquer along with the recursion. Along with the recursion. Just remember, we'll be going with the divide and conquer along with the recursion. Just remember this part, right? So I hope this part is completely clear, man. So here, let's move on with the step-by-step explanation. So here, the values we have here is 0 1 1 0. This one I'm speaking of 0 1 1 0, right? So the values we have here is 0 1 1 0. So we have the mixed values here, so they are not uniform. We have the mixed values here because we are having 0 1 1 0, right? So we have the mixed values, they are not uniform at all. So this becomes a non-leaf node. Whenever, accordingly with the question we discussed, if you remember, we have to build a quad tree such that each node represents a uniform grid region. If it is not uniform, what we have to do, we have to divide the grid into four equal subgrids. We have to divide the grid into four equal subgrids, and recursively we have to build the children. So we have discussed this one several times. I have stressed this one while reading the question as well. So if not uniform, we have to divide the grid into four equal subgrids, and recursively we have to build the children. So these things we have to keep in mind. So here in this case we have the mixed values. This is not uniform, so this becomes non-leaf node. This becomes non-leaf node, right? So we divide it into four subgrids. We divide into four subgrids of size x. We divide this one into four subgrids which is of size x, which is of size x, right? So just give me a second here. Did I forget anything? Yeah, this is fine. uh Basically, this one I think. Yeah. So this becomes a non-leaf node. Yeah. We are dividing it into four subgrids of size x, one into one. So this one four subgrids of size x, that is one into one, or you can just consider we are dividing it into four subgrids of size one into one. Right. So one into one. So this is fine. So next, let's come to the second step. Let's come to the second step here. So we have top left, top right, bottom left, and bottom right. We have to consider these part of the quadrants, right? So here of the tree, basically, we are subdividing into quadrants here because the question asks us to do the same thing. We have to go with the uniform tree, right? We have to go with the basically. So just give me a second here. One second. We have to go with the, or we have to create the quad tree such that each node represents the uniform grid region. We have to consider all zeros and ones for this, right? So here in our case it is not uniform. When it is not uniform, we have to divide the grid into four equal subgrids and recursively build the children, right? So the second step would be we have to subdivide into quadrants where it consists of the top left, top right, bottom left, and bottom right. For the top left, nothing but 0. We'll be considering 0. We are having the value 0 1 1 0. The input, the first example we have considered, right? We have considered the value 0 1 1 0. So for the top list, this is uniform. We are considering leaf, so value will be false. This is not uniform. Basically the value will be boolean value false. So here uniform leaf will considering, yes, value is true because one we have only 0 and 1 here. The 0 is false, 1 is true, again 1 is true. Uniform leaf, we are considering value equals true. Here again 0 we have, this one is false. Uniform leaf value is false, right? So this is nothing but similar to the truth table. That's it, right? So let's come to the step 3 part here. We are creating the nodes. So for each 1 into 1 grid, we will create a leaf node with that value. We will create a leaf node with that value. So we have to go with top left, top right, bottom left, and bottom right. We have to go with top left, top right, bottom left, and bottom right. So for the top left, we have true. Is leaf? Yes, it is a leaf. For all the four things, it is a leaf. It is actually a leaf. We know from this one, right? We are subdividing into quadrants. So this is leaf, this is leaf, this is leaf, this is also leaf. Is leaf part? Yes, it is leaf. All the four values 0 1 1 0, all the this thing are this one. What? True for this one, right? Boolean value true, 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 true. And the value we have here is accordingly with the input 0 1 1 and 0. 0 1 1 and 0. This is simple, right? Easy to understand. All the values we have within the input, or the values we are considering from the first example, right? So we have considered the first example. The value we have here is 0 1 1 0. So for each 1 into 1 grid, we are creating a leaf node with that value. So 0 1 1 0. These four values we need to consider. uh, so this would be the fourth step. We have to create the parent node. So before this one creating the leaf node with that particular value, let's create the parent node. So we will create a non-leaf node, that is leaf equals false. This node links the four other children from the above, nothing but the root node. Will be going with 0 comma 1 basically. Now itself I am telling. So just for the um, this one, what do we call, just for the understanding purpose I have said this one before itself. So here val can be everything. When uh, is leaf equals false, we will set this one to true by default. We will set this one to true by default, right? So you don't have to worry about this much theory. So for now just remember, so we will be creating the leaf node, nothing but is leaf equals false, and this node links the four children from above, nothing but the root 0 comma 1. Just remember this one, right? So final quad tree would be, so this will be root would be 0 comma 1. Just give me a second, where did this go? 1 second. So what has happened to this one? Just give me a second here. Yeah, this will be 0 comma 1, and see here, is leaf 0 value equals 1, nothing but 0 comma 1. So this is root, and all other values we have 1 comma 0, 1 comma 1, 1 comma 1, and 1 comma 0. Final quadtree structure that we got here as 1 comma 0, 1 comma 1, 1 comma 1, and 1 comma 0. From 0 comma 1, 0 comma 1 is nothing but root here. This is nothing but the root part here, right? So the final output would be 0 comma 1, nothing but here this one is root, and the quad tree structure 1 comma 0, 1 comma 1, 1 comma 1, and 1 comma 0. 1 comma 0, because all the values, is leaf value is having true. Is leaf we have the value true, right? We will have the value true is leaf, and the value from the input we have got here is 0 1 1 0, 0 1 1 0. So this will be 1 0 1 1 1 1 and 1 0, right? 1 0 1 1 1 1 and 1 0, quite obviously quad tree structure. And root we are doing it from 0 comma 1, 0 comma 1. From the previous step I have explained that one, explained that one. So here this would be 1 comma 0, the first one. So here the first one, the second one would be this one, what do we call, 1 comma 1 here. The third one would be here again 1 comma 1, and the fourth one would be finally here this one 1 comma 0. So overall it would be 1 comma 0, 1 comma 1, 1 comma 1, 1 comma 0, right? So this one I'm speaking of, this one I'm speaking of, right? 0 comma 1 is nothing but the root, 0 comma 1 followed by 1 comma 0, 1 comma 1, 1 comma 1, and 1 comma 0. So this is the output that we got, which is equivalent to the output that they have given for the example 1 within the question. 1 comma 0 comma 1, 1 comma 0, 1 comma 1, 1 comma 1, and 1 comma 0. So this is the output that we got. This is the output that we have got basically, right? So I hope this part is completely clear, man. I hope the output part is completely clear. I mean, yeah, I hope the approach part, basically not the output part, I hope the approach part is completely clear. So whatever the output that we got is equivalent to the output that they have shown for the, or that they have given for the example 1 within the question. So our approach works absolutely correct in this case. So as we are completely familiar with the approach, let's discuss the complexities, right? Or let's move on with the complexities part. So the time complexity would be big of n square here. Why it would be big of n square here? Because we will be visiting every cell once once uh, because of the recursion, right? So we are going with the divide and conquer method. Due to divide and check here, every cell is visited once in the recursion. So overall time complexity would lead to big of n square. So overall time complexity would lead to big of n square. So the overall space complexity would be big of logarithmic n, because recursion depth is logarithmic n. As we divide size by 2, we are dividing the size by 2 for this particular problem each time. As we are dealing with a quad tree structure, we will be going with the recursion depth. As we are dividing the size by 2 each time, we will be going with the recursion depth of big of logarithmic n, right? For this particular problem, usually recursion depth is of big of n. for this particular problem, we are dividing the size by 2 each time. So the recursion depth is logarithmic n rather than the big of n. So overall space complexity would be big of log n, and overall time complexity would be big of n square, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n square and big of log n, right? So now, as we are completely familiar with the complexities and the approach part, let's start writing the code. So let's start writing the code. So the first step here is we'll be making use of the length of the grid everywhere. So let me assign this one to the some variable. I'll just assign this one to the n here. So I'll just give grid dot length. This is fine. So the next step would be here. So we have to start building from the top left, nothing but 0 comma 0 of size n, right? So I'll just return here in this case. Uh, so for building, we'll be making use of the helper method. So we'll be making use of the helper method here. So before making use of that helper method within the main function construct here, so let's write the this one. What do we call helper method? So I'll just go with private. This one will be node. This one will be build. The parameters we'll consider here as uh, this one. What do we call grid? Parameter we'll consider this one grid. So this one will be int row, this one will be int column, and also this one will be int size, this one will be int size. So within this particular method, so what we'll be doing here, so we have to check if the current region is uniform, means all the values are same or not, right? So in our case it was not same, uh, not uniform, right? So we have to split into four quadrants, right? So that's what we did, and finally we built the this one, what do we call, quad tree, based on that if not uniform. So we have to check if first we have to check if the current region is uniform or not, means all same or not values. So let me write the simple if condition for this is uniform. uh, so for this we have to check whether this is uniform or not, right? To check this one, I'll be making use of one more helper function is uniform. So I'll just go with here private boolean here. So this one is uniform. So this one will be again the parameters, it will consist of mm, it will consist of grid and row, and this one will be in column, and this one will be int size. So this is fine. So within this method, so first let's assign the value to grid of row and column. We are checking whether all the values are same or not, or whether this is uniform or not, right? So let's go with the nested loops here, for loop. So int I equals row I less than row plus size. Let me increment this one. Same thing for let j equals, we are going with rows and columns, right? J, let me assign this one to column. J less than column plus size, and also j plus plus. This is just for the bounds basically. We are checking the bounds, right? So here simple if condition I'll write, man. So if the value of ij means grid of ij, if it is not equal to the particular value, means if the values are not same, then we have found a different value. In that case we have to return false, else we have to return true. That's what we need to do. That is the reason we have made use of the helper function is uniform. That's it, we have to write, right? Simple one, man. So this one, let me go with grid of I j. If it is not equal, if the values are not same, if it is not equal to val, then let me do one thing. Let's return false, else let's return true here, else let's return true here, right? So I'll just return sorry, else we have to return true. Yeah, correct, this is correct, this is fine. So now we can make use of the is uniform, this one is uniform method within the build method, right? So I'll just go with the same thing here, is uniform where we have left. So this is the first step, right? So we have to check if the current region is uniform or not. is is uniform of what are the parameters here. So this is nothing but grid, row, column and size. So this is fine. So within this is uniform method, so we will be going with the means if it is uniform, then we have to get the value. We have to get the value. So after that we have to create a leaf node as well. If it is uniform, then we have to get the value and then we have to create a leaf node. These two things we have to do. First, if it is uniform, then let's get the value. For that one, I'll be going with Boolean val. But let me assign this one to the grid of row. This one would be column. So this one would be column. So this is fine. So this one we have to assign this one to 1. This is fine. So now we have to create the leaf node next step, right? So as I've said, I'll just go with a return new node of, let me pass value and true. This is fine. So this is it for the first step. Next, let's carry on with the next step. Let me come out of the if condition entirely. So now as we had discussed in the approach, we will be going with the divide and conquer. So we have to divide the region into 4 equal subgrids. So we have to build the this one quad tree, if you remember, right? In the approach, if you remember, if it is not uniform, then we have to divide the region into 4 equal subgrids. So let's do that one. So first, let me go with half and I'll just assign this one to size by 2, right? So the next step is node. This one will be top left. Let me assign this one to build. This one will be grid, comma, row, comma, column, comma, this one half, right? So let me copy this one 3 more times and make the necessary changes here. So instead of the top left, this one will be top right. This is fine. So this one, instead of the top left, this will be bottom left. Instead of the this one will be bottom right. Bottom right. This is completely different, right? So this one remains same. Build of grid, row, column and half. For the top right, we will be going with column plus half. So for this one, we will be going with column plus half because this is top right, right? So the all other things parameters remain same. So for the bottom left, we will be going with row plus half. So this will be row plus half, uh, column and half. This is fine. And for the final one, bottom right, we will be going with build of grid. So this one will be row plus half as well. So this one will be row plus half and column plus half both. So this will be row plus half as well as column plus half. So this is fine along with the half. So I hope this part is completely clear, man. I hope this part is completely clear. Now we are left with one last thing, nothing but we have to return the parent node with 4 children and easily if is false, right? So this thing we have to do. Just give me a second here. So here this would be we have to return the parent node with the 4 children and easily if equals false we have to check, right? So I'll just return on this way, return new. So this one will be node of true comma false here. So this will be top left. So we have to include one by one. So this one, let's include this one by one. Top left. This one will be top right. So the next one we have use the variable name bottom left. So this one will be bottom left and the final one would be bottom right. So let me give bottom right here, right? So this is fine. So we are done with the third step as well. So we are done with this method, basically build method. So the last step what we did, we just returned parent node with the 4 children and easily if equals false we are checking, right? So basically we had returned parent node with 4 children. That's what we need to return for the output. For the output, right? If you remember, we included the root 0 comma 1 along with the 4 children, for the output, right? So that's what we are doing it in the build. So here let's make use of the build method within the main function construct. So here let's go with let's go with build build let's go with the build. So this consists of the parameter grid 0 comma 0 comma n, nothing but we are starting we have to start building from top left 0 comma 0 of size n. We have to start building from top left 0 comma 0, the first the first cell basically, right? We have to start building from top left 0 comma 0 of size n, of size n. So that is the reason we are considering grid 0 0 and n 0 comma 0, nothing but two zeros we have considered. N means which is of size n basically, and grid is nothing but we are considering the grid, right? So parameter grid, this one, right? So this is fine. I hope the solution part is completely clear, man. This is it for the code. Let me format the code once and let me hit the run button. Simple problem, divide and conquer. So here private, I have misspelled here, line number 7, just give me a second. So whenever the problem is huge, if we feel that problem is big, so it is better we split the problem, or uh, we segregate the problem into different parts, right? Sub problems, and then we solve it. Same thing we are doing here as well, right? So we are going with a, basically we are going with the divide and conquer method itself, right? uh, so basically this is it. So I'll, why here this one, so just give me a second here, private node build. So yeah, let me run this one again. Have error semicolon except, oh yeah, this one I have to give semicolon. This has become comma here. Why? Line number 24. So I gave comma, I think, I don't know. So here let me give semicolon. So again in the line number 24 row plus size, yeah, this is fine. Let me hit the run button again. So we have three more errors here. Cannot find symbol grid dot length, where line number 3 we have grid, right? So what is the problem here? So yeah, I have given parenthesis here. Let me run this one again. We have one error, that is I have given let. So we cannot forget JavaScript anyhow. So I have to give int here. So line number 25. So this has to be int. So this has to be, yeah. Now this has to work. Let's see. So here you can clearly see, right? So the sample test cases are getting passed. So let me hit the submit button. So I hope this works for all the test cases, man. Let's see. So you can clearly see here all the test cases are getting passed. Once the code works absolutely correct in this case, right? So I hope the solution part is completely clear, right? So here uh, basically we are making use of two helper methods. One is build and another one is uniform. So we can go with a build this one method. So before without writing build method also, we can just write the code in construct itself directly. But it is better when we make use of the helper methods, right? So the code will be clean, and we understand this one better as well. So that is the reason I have went with two helper methods. One is build and another one is this one is uniform, right? So I hope this part is completely clear, man. Means I hope the solution part is completely clear along with the approach and complexities. For now, this is it. Thanks for watching, guys.